Every single time you go online, there's this invisible, super high-speed ballet happening just behind your screen. We're about to break down a process that happens billions of times a second all over the world. So let's pull back the curtain. I mean, it feels instantaneous, doesn't it? You click on a video, a news story, whatever, and boom, there it is. But that boom is actually an incredible globe-spanning journey. So what is really happening in that tiny fraction of a second? To really get this, we're going to follow a single tiny hero. We are going on the grand tour of a little piece of your request, a digital messenger that we call a packet, as it travels from your screen out into the wild world of the internet. See, the strategy here is actually really clever. Trying to send a huge file all at once would be like, trying to ship an entire house in one giant box. It's just not efficient, and if anything goes wrong, you've got a huge mess. Instead, the internet breaks your requests down into these small, manageable packets. That way, if one gets lost, you only need to resend that one tiny piece, not the whole shebang. Okay, so before our packet can hit the road, it's gotta get ready. You can think of it like packing for a big international trip. It needs a passport, a destination address, instructions on how to get there, all that stuff. In the digital world, this means our packet gets dressed in layers of information. And this whole process is governed by something called the TCP/IP model. It's basically a set of rules or protocols that act like a digital dressing room. Each layer adds a new piece to the packet's outfit, a process we call encapsulation, wrapping the original data in all the instructions it's going to need to arrive safe and sound. The journey kicks off right here at the application layer. When you type in a web address and hit enter, your browser creates a request using a protocol like HTTP. HTTP just stands for Hypertext Transfer Protocol. This is basically the content of the message itself. Hey, can you please send me the data for this specific web page? Next up, the transport layer takes over, and this layer is like a super organized shipping clerk. It chops that HTTP request into our hero packets, and this is crucial, it numbers each one. This is the TCP part of TCP/IP, and its whole job is to make sure the delivery is reliable and in order. It even waits for a little thank you note from the destination, an acknowledgement that each packet arrived. If it doesn't get one, TCP just sends that packet again. It's a guarantee that nothing gets lost along the way. All right, now for maybe the most important part of the outfit, the address. The internet layer stamps each and every packet with a destination IP address. That's the unique address of the server it's headed to, and a source IP address, which is your computer's address so the response knows exactly where to come back. This is the IP in TCP/IP, the global postal code of the entire internet. And finally, the network access layer gets the packet ready for its very first physical step. It translates that digital packet into electrical signals if you're on a cable, or into radio waves for Wi-Fi. It's the final instruction that says, okay, you're all set to physically move out. So, with our packet fully dressed and ready to go, it's time to hit the digital highways. Now, this journey happens on one of two main types of highways. You've got your wired networks that use physical cables, and you've got wireless networks that use invisible radio waves. Most of us, we use a mix of both every single day, and we don't even think about it. And this really highlights a fascinating kind of weird duality, right? On one hand, you have a coaxial cable with a real copper conductor inside, a tangible, physical thing running under our streets. On the other hand, you have radio waves just moving through the air around us. The internet is both this incredible feat of physical engineering and, at the same time, this seemingly magical, invisible force. So what's the bottom line for you? Well, wireless, it gives you that awesome freedom to move around. But you might notice your connection gets a little choppy if there's a lot of signal interference, like from your microwave or your neighbor's Wi-Fi. A wired connection, though, it tethers you with a cable, but it gives you that rock-solid stability and speed because interference is pretty much a non-issue. It's that classic trade-off, convenience versus reliability. Okay, so our packet has left your device and it's now on your local network, whether that's your Wi-Fi at home or the network at your office. But how does it find its way from your little corner of the world out onto the massive global internet? Well, the first stop is probably a device called a switch. A switch is smart. Instead of just shouting the packet's information out to every single device on your local network, it looks at the address and forwards the packet only to the next correct device on its path. Think of it like an internal mail sorter in an office building, making sure your data goes straight to the main router, not to your coworker's printer by mistake. And then it gets out onto the wider internet. And just look at this. This is what the internet's backbone actually looks like. A huge, sprawling web of interconnected networks. And the devices that connect all these networks and guide the traffic between them, those are routers. They are the true gatekeepers of the internet. And this is the router's critical job. It's the master traffic cop. You see, where a switch directs traffic within a single network, a router's job is to connect different networks together. When our packet arrives, the router inspects that IP address, it checks its internal map of the internet, and makes a split-second decision on the most efficient path forward. Our little packet might make dozens of these hops from router to router across cities, countries, and even under oceans to reach its final destination. After hopping across the global network at nearly the speed of light, our heroic little packet is finally nearing the end of its outbound journey. And touchdown! The packet, along with all of its siblings, arrives at the destination server. Now, that whole dressing process we talked about, it happens in reverse. The server unpacks each layer, puts all the packets back in the correct order using their sequence numbers, and finally, it gets to read the original HTTP request. Please send me the web page. And what is just mind-blowing is that the entire process we just followed now happens all over again, but in reverse. The web server now becomes a sender. It creates a brand new set of packets carrying the website's data. It dresses them up in their own TCP/IP layers using your IP address as the destination and sends them flying back across the internet, guided by that very same system of routers, all to find their way home to you. And that's it. The packets arrive back at your computer, they're reassembled, and your browser displays the web page. This entire round trip, this perfect, ridiculously complex dance, happens in the time it takes you to blink. It is an absolute testament to the power of these standardized protocols, the shared language that lets all these different devices from all over the world cooperate perfectly. So, this system works beautifully today, but as we connect everything from our cars to our coffee makers to the internet, you really have to wonder, what does the future hold for our little data packets? What new challenges are they going to face, and what new rules, what new protocols will we have to invent to guide them on their journey?